Number 17 on homework 4.1. So we got to digest it a little bit. So let's get that. All right, take a picture. On the federal income tax returns, self-employed people can depreciate, meaning it's going to growth. It's not going to be growth. It's going to be decay, right? It's good. So just kind of make a note. That means decay, right? Depreciate the value of the business equipment. That makes sense, right? You buy some equipment and it goes down in value, whatever it is. Some things depreciate really quickly, some don't, right? You'd be surprised. Those big cats, those big machines that they use, they actually don't go down in value. They go down quickly, really quick, and then they kind of they level off, and they don't usually go down from that point, right? So it's like they go down, but then they kind of stay right there at a certain level, and as long as they're running, they're always going to be worth that much. It's not until they stop running do they go down, right? So it's really important to understand this as a businessman, is how your stuff depreciates. About 5 exabytes, or 5 times 10 to the 18. Wait, am I in the right one? No. Oops. Started reading the wrong one. Okay. My bad. Depreciates the value of the business equipment. Suppose a computer valued at $2,765, which is a pretty nice computer. 765. Okay, so that I'm thinking is going to be my A. So depreciates at a rate of 30%. So I should know right now my R is 0.3. Instead of writing 30%, I could write 30% here, but then R is move that decimal over twice, and you got 0.3, right? 30% is a lot. That means a third of it's gone every year. You know, what it's worth. Okay? Estimate the number of years it will take for the computer, the value to get less than 350. Okay? So we don't know the time, but we want to know the time when A is equal to 350, or actually A is less than or equal to 350. Okay? So, well, they should say less than, so we'll just say less than. When A is less than 350. Okay? So, come back to the actual board. Let's take a look and see what we've got here. All right? We've got A is 2765. Okay? R is equal to 0.3, which was 30%. Okay? T is what we're looking for. And then when A is less than 350, right? And so now I have all that rewritten up here in a nice line so I can start thinking. How am I going to think? Well, first of all, I'll think with the equation. A sub t is equal to A times, remember it's plus or minus, but it's plus or minus R. So in this case it's minus R, and it's 1 minus R to the t. Okay? And the reason why it's 1 minus R is because it's worth 100%. It's 1. Right? But then when you take away 0.3, how much is left? No, 0.7, right? So what's left is how much you're going to multiply this against, right? In order to get this amount. So what we're saying is the original amount was 2,765. This is 1 minus 0.3, which is 0.7. This is unknown, but it's going to equal this amount, which is 350. And in fact, it's not going to equal it. We decided that this was going to be less than that, right? Okay? And so, I know that sometimes it's hard to see the orange. Sorry about that. So then, what do we do with this? Now, we can go to our trusty-dusty calculator, which is our computer, right? And we could type in I don't know. Oh, there we go. 0.7. And we could change this. What is the number? 2765. Let's move the camera over here. So what we did was we just put that formula in the computer, and so now we need to kind of move this up. We don't need to. Let's see. We'll go out. We'll move this up here. Oh, that was nice. And maybe. Oh shoot! What the heck happened? Okay, that's crazy. What did I do? Oops. Alright, don't do that. Let's go back. Let's try that again. I'm like messing up. Okay. And then what did we do? We said it was 27.65 and times 0.7, right? And then raised to the power of x, right? Oh, and we need to actually say that y is equal to this, right? Do I need to put times here? What's wrong? Why isn't it graphing? Come on, guys. I used a different, oh, because I used t, didn't I? Y is equal to 2765 times x, no, times 0.7 raised to the x. Oh, there it is. Okay. So, we want to know, oops, when it is, how much?
What?
How much do we want to know? 350. So we're looking at, when is it going to be 350? And it looks like somewhere around 5.7. 5.79. Okay, so 5.8. Okay, and that gives us a real good, accurate thing. So when it becomes less, right, is probably going to be 6, right? As it goes that way. So we're talking about t is equal to 6. Okay? And what we would do to figure that out without that graph, right? A lot of you are like, well, I don't have a graph on my calculator, and I don't have that computer at home. And well, obviously you can just get this. It's free on the internet, right? But what you would do is you would plug in 3. How much is that? Oh, it's going to be above 350. Plug in 4, above 350. Plug in 5, above 350, right? Plug in 6, less than 350. Right? And so, when you plugged in 6, you found that this goes below 350. And what we're trying to show you is there's got to be a better way than just plugging in stuff, right? But for right now, this is your way. This is what you have. Okay? And come next week, we're going to learn logarithms. We're going to use logarithms to figure out the exponent. Okay, so that is problem, what is it? That was 17?